So I have a data engineering interview coming up, and I kind of wanted to learn more about data engineering topics and data pipelines and things like that. So what I did was I watched a 3.5 hour video on YouTube on data engineering, and after half of that video, I was like, man, I have no clue what the hell he's talking about. So I was like, you know what? I'm just gonna make a project. So the interview that I'm doing, or the company that I'm interviewing with, the company name is Oshkosh Corporation, and they use or they create automotives and specialty vehicles like uh, dump trucks or like big specialty vehicles basically. And I'm like, okay, I was thinking these kind of vehicles are impacted by weather probably because I used to work in the construction industry as well, and like we don't work during the winter. So I would guess that maybe weather conditions could have a play a role in the company. So maybe I could correlate both weather and the company together. And then I also realized that the company Oshkosh Corporation has a stock, so maybe I could correlate weather with their stock price and see if they correlate. But what a data engineer does, from what I researched, is that their job is mainly to grab data rather than analyze data. Their job is to grab data for and put it into one place and give it to data scientists for them to analyze. The main focus of the project that I'm going to do right now is to create kind of like a data pipeline where it automates taking in information rather than analyzing. So yeah, here's a showcase of that. So the technologies I use is Docker and Airflow. And Airflow is kind of what automates it. So Airflow will run and grab the data from the weather API and the stocks API that I have, and it goes through this ETL script. ETL stands for extraction, transformation, and loading. So it extracts the data, it transforms the data to how I want, and then loads it into a database. And what Airflow does is it automates that process. So every single day it'll run the script and automate it for me. And then what Docker does is it containerizes is what they call it. They containerizes the application so that it can work in any single environment rather than just my own environment. So the way to run this is to go Docker compose up, and I'm gonna pause it to wait for this to actually load. All right, so now it's loaded, and it's loaded onto port 8080. So if I go into here, it'll pop up the Airflow UI. So I can go Airflow, and the password I have set is Airflow as well. And this is my DAG. So DAGs are, DAG in math, it's called directed acyclic graphs. And basically, in this case, it kind of just, it's an automated process to go from to do one task to another task to another task. So it's a graph going in one direction. The graph that I have basically extracts data, it transforms that data, and then loads that data. So there's 3 different steps in that DAG, or direct acyclic graph. So if you go into here, and so it says like, so the automated part is it schedules it every single day. So next run is tomorrow, and then it'll run every single day. So it grabs up-to-date data from the APIs that I have. And the APIs that I have, it basically grabs stock data and weather data, puts them together. It's pretty simple. It's basically what it does. So if we trigger the DAG, I kind of just want to show that's working. So it extracts the data and then it loads the data. So what is that data actually? So let's go into here. We first have to go into the Docker database. So right now the Docker instance is running. So to get into Docker, we have to grab the container ID. So something like this. And then we go Docker exec-it, and then bash. So now we're in the container server. So if we run this, now we have our DAGs and data. So where I have it stored is in data, and it's an SQLite database. So I can run SQLite 3 data.db, And in here, I can list the tables. And so we have the stock prices, weather data, and combine it. So stock prices is what I grabbed from the stock API, and weather data is what I grabbed from the weather API. So if you want to take a look at that, select the stock prices, or select star from stock prices, stock prices. So this is 20 years worth of data for the stock prices, and then tables, select star from weather data, and this is weather data. The weather data is only 1 year, and the stocks was 20 years. It's just because I grabbed as much information as I could for the free versions. So for the weather, it's a lot more restricted than the stock prices. And then what I did was combine them or join them together and related them together by the date. So if we take a look here, this is going to be the tables. Oh, not the tables. Select star from data. And this is kind of what that information looks like for a whole year, the stock price versus the temperature in Celsius. And then to get an actual visualization of this, let's exit that. I made this plot.py program. So if you plot it, it grabs the, hold on, I have to go into the view, then activates, and then plots.py, and it'll output a figure. And this is kind of what the figure looks like. So I'm not, it's very rudimentary data analysis. However, what I can generally see here is, okay, the temperature goes up and the stock prices go down, and the temperature goes down, stock prices go up. It could be due to other factors, but this is kind of like, oh, this is pretty cool comparison that I can see, and maybe it could be useful. I don't know. So there we go. That is my Sky market trending data engineering project.